Dundigal. My name is B. Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about addressing modes. So there are so many types of addressing modes are there. Implied or implicit addressing mode, stack addressing mode, immediate addressing mode, direct addressing mode, indirect addressing mode, register direct addressing mode, register indirect addressing mode, relative addressing mode, indexed addressing mode, base register addressing mode, auto increment addressing mode, auto decrement addressing mode. So before starting to these types of addressing modes, so what is addressing mode? Suppose any of the opcode or any of the instruction I am taking as, suppose add ax comma bx. So when I am going to this add ax comma bx or micro program, any of the micro program into 03, suppose it is a micro program. So this micro program shall I store in a memory, as we need a memory to store this program or micro program. So shall I need this one is, shall I call this is memory address register? Yes. So every program we need memory data register and memory address register. So without address we can't store any of the opcode or any of the instructions, so any of the program. So before going to start or execute this program, we need address to store this one. So every instruction that is add x comma bx or into 03 or whatever may be, so any of the instruction we need address for this one. So how can you define the instruction? How can you define, what is the process to define the instruction in a program? So there are so many types of addressing modes are there regarding for the instructions. I'm talking about the instructions. Okay. So first one is a implied or implicit addressing mode. So few in this, all those things, only few are very important. We'll discuss only what are the important instructions are addressing in that one. We will discuss, not all. Stack addressing mode, immediate addressing mode, direct addressing mode, indirect addressing mode, register direct addressing mode, register indirect addressing mode, relative addressing mode, indexed addressing mode, base register addressing mode, auto increment addressing mode, auto decrement addressing mode. So these are the addressing modes are there. So each one, how can we define the instruction? How can we define the address for the each instruction? We can discuss. So addressing modes, the term addressing modes refer to the way in the which the operand of an instruction is specified. The addressing mode specifies a rule for interpreting or modifying the address field of the instruction before the operand is actually executed. So implied mode. In implied addressing, the operand is specified in the instruction itself. In this mode, the data is 8-bit or 16-bit long, and the data is a part of instruction. 0 instructions are designed with implied addressing mode. So how can you define the address? So in the address, we'll define in the form of registers. Any of the addressing mode we can define in the form of registers only. Or so registers are maybe 8-bit or 16-bit size. So any of the addressing mode you have to define in terms of in the form of registers. So how can you define addressing modes? The term addressing modes refer to the way in which the operand of an instruction is specified. So add ax comma bx, operand, opcode and operand, opcode and operand. So any of the instruction, what is the operand? This operand we are taking as a address of the operand. So any of the opcode we need an address. We need address. So opcode with address I need. So any of the opcode will be changed, but in the operand address means in the form of registers. Yes, in the form of registers only we have to define. So address will be defined in the form of registers. So any of the addressing mode, it refers to the way in which the operand of an instruction is specified. Suppose here I am taking add ax comma bx is an instruction. Yes, it is an instruction. The instruction which consists of opcode and operand. But here operand is defining in the terms of address. Opcode is nothing but it is the ALU, arithmetic logic unit, or anything. But shift, rotate like this. There are the opcode. So opcode, there is a different opcodes will be changed. But operand is nothing but it is a type of register which are defining the address. So this addressing mode specifies a rule for interpreting or modifying the address field of the instruction before the operand is actually executed. So suppose I give an opcode or operand, this one ax comma bx. This operand I given one address. What is address means? M of AR. That is the memory of address register. So maybe I have to change the address. Is it possible? Yes, it is possible to change the address. So this addressing mode specifies the interpreting or modifying the address field of the instruction before the operand is actually executed. So what is the original address of the instruction? What is the edit or specifying or changing of the address? So is it, suppose I have the direct addressing mode. Shall I change to indirect addressing mode? Yes, it is possible to change the indirect addressing mode. So that instruction before the operand is actually executed. So another one is an implied mode. In implied addressing operand, it specifies in the instruction itself. This mode, the data is in the form of 8 or 16 bit size. So any of the addressing mode I am taking as in the form of register. This register I am taking as in the form of 8 bit or 16 bit of size or long. And the data is in the part of instructions. Any of the data I am taking as in the part of instructions only. So 0 instructions are designed with the implied addressing mode. So any of the instruction I am taking starting from 0 addressing mode, 1 addressing mode, 2 addressing mode like this. So I am taking as a 0 address instructions are designed with implied addressing mode. Suppose here I am taking one instruction. In that instruction, what is there? The data is there. Operand. This operand is, what is operand there? The data is in the register. So the data is stored in the register. The data is stored in the register. What is the register size? Maybe 8 bit or 16 bit. So maybe I am taking this data is in the form of 8 bit or 16 bit. Depends on my data size. My data is large, then I take the 16 bit. My data is small, then I take the 8 bit. So this data will be stored in register. This register I am taking as a operand. So shall I need this address for this one? Yes, we need an address for this operand. Immediate addressing mode. So in this address, opcode I defined, in place of operand I am taking the address. So what is the address? So maybe that the address is the direct addressing mode or indirect addressing mode, but here I am taking the immediate addressing mode. So in this mode, the data is present in the address field of instruction. Designers like one address instruction format. Limitations in the immediate mode in the range of constants are restricted by the size of address field. So here I am taking one immediate addressing mode, that is opcode I defined. Here opcode anything, move, add, mul, like this. So any of the opcode I will define, but in the place of address or in the place of operand, address is in the form of I am taking the data is directly stored here. So in place of address, what I am taking, data I am taking, data is directly stored here like this. So here the instruction is there. It is opcode. Yes, it is a opcode of this one. So in this opcode, the data is operand. Yes, it is a operand. So this operand, actually the address will be there. In this address, I am defined the data directly. Here also in the form of address, the data is I am defining directly. The data is directly stored here. Example of this one means move AL comma 35H. Here move the data 35H into AL register. So move is opcode. Yes, it is the opcode. And what is address here? AL comma 35H. So move is the opcode. It is a operand. Maybe this operand I'm consisting of address, but here I'm taking 35H is a data which are stored in AL register. So AL register is stored 35H value. So what is AL means? It is a lower order. Yes, it is a lower order, but it means 0 to 7. That means a 8-bit data. So 8-bit register, 8-bit register. Why I am taking here 8-bit means here I am considering AL means lower order, means AL means the register name is A and the L is a lower order values, that is from 0 to 7. That is a 8-bit data is stored in a register A. What is the data is stored? 35H value is stored in AL register. So it is the immediate addressing mode. That means in place of operand address, we are directly defining the data in the address. So opcode, operand. In this operand, maybe I am defining address or data of this one. So sometimes we will define address, sometimes we will define data. If we will define address, what we are calling this one. If we are storing the data, what we are calling this one. So this operand defining with address or data, but this opcode will be anything. I am taking as a move, add like this. So in the previous example also, I am taking move, that is a opcode. AL, 35H, we are defining the address of this one. So register mode. In register addressing, the operand is placed in one of 8-bit or 16-bit general purpose registers. The data is in the register that is specified by the instruction. Here one register reference is required to access the data. So register mode means which type of register we are taking for the address. Register mode. So this register mode I am taking the addressing of the operand is placed in address of 8-bit or 16-bit. This address are I am defining as 8-bit or 16-bit. So the general purpose registers, GPR, general purpose registers, are the data in the registers that is specified by the instruction. Okay, so regular registers will be different and general purpose registers are different. So in the general purpose registers, the registers of addressing mode, that is we are defining in the general purpose register to defining the data or address. So this data is in the register that is specified by the instruction. Here one register reference is required to access the data. So here instruction, shall I need register? Yes, this instruction we need a register. This register I need a data. So instruction with register. So any of the instruction. So in this AX, BX, maybe the address is there or data will be there. This address or data will be stored in the register. Yes, it was stored in a register. So the instruction with operand is stored in a register. It is 8-bit or 16-bit, depends on the size of the data. And this register is consisting data. Yes, this register is consisting of data. Which type of data? Maybe I will take AX, BX values. That is AX, BX means I am taking as AL, 35H or BL, 40H like this. So maybe the data is in the form of values. Okay. So any of the instruction we are considering as register, any of the register it will be considering as a data. So register indirect mode. In this addressing, the operand's offset is placed in any one of the registers BX, BB, SI, DI as specified in the instruction. The effective address of the data is in the base register or an index register that is specified by the instruction. Here 2 register reference is required to access the data. So I am taking register indirect mode. Here previously we discussed register mode. Register mode means it is a addressing mode or data mode. But here indirect mode. Indirectly we are addressing, not directly we are defining. So here in the place of instruction I am taking register. In the place of register I am taking data. It is direct. But here I am taking indirect. In this addressing, the operands offset is placed in any one of the register BX, BP, SIDA as specified in the instruction. The effective address of the data is in the base register or in the index register that is specified by the instruction. Here 2 register reference is required to access the data. Previously we are taking only instruction and register. That is a direct addressing mode. But here now register indirect mode. But what is the reason? We are taking instruction, register and memory. So in the instruction it is considered as a register. In the register it is considered as a data. But here indirect. Indirect means in the register we are not taking data. We are taking address. In that address the memory will be there. That means register direct mode means any of the instruction I am taking is in the form of register. So this instruction I am taking in the form of register. So in the register the data will be there. Data will be there. Okay. So instruction is a register. In the register we are considering data. But here I am taking instruction. This instruction is considered as a register. This register is a address mode. In this address I am considering as a data or memory. So here instruction, register, data will be considered. Here instruction, register. In that register the data is in the register the data is there. Here in that register the data will be not there. Only the address will be there. In the register only the address will be there. In that address we are specifying the memory address. In this address we are specifying the memory address or effective address. Effective address means where is the data location. We are in the register we are giving the location of the data. What is your data is searching, thus that data address I will be defined. You can search. Okay, register in the place of data I will give the effective address. In that address the data will be there. In that address the data will be there. So instruction, register, in that register address is there. Address is defining the memory. In the memory data will be stored. Okay, what is the instruction for this one? One example, move AX of BX. This brackets means I'm specifying the address. I'm specifying the address, that is called indirect. When I'm calling this one, that means the indirect addressing mode. Or defining the address. So move AX of BX, that means move the contents of memory location as address by the register BX to the register AX. The BX values are storing in AX, but BX values are there directly? No. Here the BX I'm defining the address. In that address the data is there. That data is replacing. That data is storing in AX register. That is the indirect addressing mode. So how can you define means we are defining with brackets. So in the register indirect mode, I need instruction, register, then memory. Auto indexed or increment mode. Effective address of the operand is the content of a register specified in the instruction. After accessing the operand, the contents of this register are automatically incremented to point to the next consecutive memory location R1 plus. Here one register reference, one memory reference and daily operation is required to access the data. Suppose auto indexed means incrementing mode. Suppose R1 some value is there. next I have to increment, that is the R1 plus, means we are incrementing the next value. So how can you incrementing means I am using here ALU operation, arithmetic logic unit, to incrementing the value of R1 register. This effective address of the operand in the content of a register specified in the instruction. After accessing the operand, the content of the register are automatically incremented to point to the next consecutive memory location. Here, one register reference, one memory reference, and one ALU operation is required to access the data. Suppose I am taking one example, add R1, R2. What is the meaning of this pun? I'm defining the address. Here I'm not defining the data. Here I'm defining the address. R1, R2 plus means. So in this address, what is the data? That data should be incremented one. R2 means, in the bracket means, I'm defining the address, not the data. I'm defining only address. Go to this address and take the data and increment the value. R1 equal to R1 equal to R1 plus M of R2. That means in this R2 register, that is defining the address. In this R2 address, what is the data in that address? That data is adding with R1 value. This total resultant value is storing in R1 register. Here R2 plus D value. So what is the D value? That D value is adding with R2. The resultant value is storing in R2 register. So it is useful for stepping through array in a loop R2, starting of array of D size of the element. So here it is a addressing modes, auto indexed or decrement mode. The effective address of the operand is the contents of its register specified in the instruction. Before accessing the operand, the contents of these registers are automatically decremented to point to the previous consecutive memory location of R1. Okay, and one register reference of one memory is ALU operation is required to access the data. Here I am taking R2 address and defining the R2 address. Go to that address. In that address, what is the value that will be decremented? Means we are minus that one. So under the auto index will decrement. Here, direct addressing or absolute addressing mode. The operand's offset is given in the instruction as a 8-bit or 16-bit displacement element. In this addressing mode, the 16-bit effective address of the data is part of the instruction. Here, only one memory reference operation is required to access the data. So here I am defining the instruction. The instruction is in the form of registers actually, but in this register I am defining the address. Actually, this one I am defining in the form of register only instructions. But here in the form of registers, in place of registers, I am taking the effective address, not the register. Okay. This effective address is defining the address of the memory. In that memory, the data will be there. Example, add AL, bracket of 0301. That means in this address, the value is 0301. The content of offset address is 0301 to AL. So, direct addressing mode. That means opcode I am defining. In the operand, I am giving a register A. This register is a operand. So, this operand directly I am defining here. In the memory, operand is directly defining. Okay. This operand is a register A. In that register A, what is there? The operand value is there. So, it is a direct addressing mode. Indirect addressing mode means in this mode, the address field of the instruction contain the address of the effective address. Here, two references are required. First reference to go to the effective address. Suppose I am taking register direct addressing mode, opcode, and it is a operand. Operand is a register R. In this register R, the operand value will be there. That is a register set. Here I am taking memory. In the memory, the operand is there. Here in the register set, the operand value is there. That is add R will be increment the value stored in the accumulator by the content of the register AC. So that means accumulator is tends to accumulator plus address of R. In the R register, what is the address that will be stored? The R value address of this register. What is the value? This value is added to the accumulator and the total value is added to the accumulator. So it is a register indirect addressing mode. That means opcode is there and operand is there. This operand I am taking as a register, or in this register I am not defining the data, just I am defining the address. We can go to this address and search the data at that one. So operand, it is the address, effective address. E is nothing but the effective address. So this register is defining not the data. This defining is address. It is defining the address. Go to that address and take the value. That value will be stored in a memory. Okay, it is stored a data. Okay, it is defining a memory. Go to that memory and take the address, or take the data through the operand. So here add or will be incrementing the value stored in the accumulator by the content of the memory location specified in the register or. So accumulator tends to accumulator plus or, means go to this address and take the value of or, and that value is in specified address. Effective address is there and that effective address data value is stored in accumulator. The total accumulator value is stored in another accumulator, total accumulator. Next, relative addressing mode. In this addressing mode, the effective address of the operand is obtained by adding the content of program counter with the address part of this instruction. That is the effective address. The content of the program counter plus address part of the instruction. It is a relative addressing mode. That means opcode with register A. This register A is defining the memory or data. It is a data. Okay, this register is directly defining the data, or it is defining the program counter, means next instruction it will be defining. So there are the different types of addressing modes. Immediate addressing mode. What is application means? To initialize the register to a constant value. Next, direct addressing mode and register direct addressing mode. What are the applications through this means? To access static data, to implement variables. Indirect addressing mode and register and addressing modes are to implement pointers, because of pointers or memory locations that store the address of another variable, and these are arrays as a parameter because array name is the base address pointer is needed to point the address. And next is a relative addressing mode for program relocation at runtime, that is for position independent code. To change the normal sequence of execution of instructions, the branch type of instruction, since it directly update the program counter. And indexed addressing mode for array implementation of array addressing. For records, it is implementing as a array addressing. And base register means to writing relocatable code, that is for relocation of the program in memory even at a runtime, for handling recursive procedure. So these are the addressing modes with effective applications. And base register addressing mode for writing relocatable code, that is for relocation of program in memory even at a runtime, for handling recursive procedures. Auto increment addressing mode and auto decrement addressing mode for implementing loops, for stepping through arrays in a loop, for implementing a stack as push and pop conditions. These are the references. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.